Okay guys, hey, it's Mr. Morrissey. Part 2 of solving rational functions. Let's start this problem straight away and factor the numerator and denominator, two difference of squares. Okay. Let's head right into a graph, all right? We're going to notice that at 5 and at negative 5, we have a vertical asymptote. And we're going to notice there's a horizontal asymptote at the ratio of x squared over x squared. So x squared over x squared. Well, remember, like if you were to do infinity squared over infinity squared, those would cancel and give you 1. So in this case, there is a horizontal asymptote at y equals 1. Okay, so you could test some points, but the general shape of the curve in the two sort of side regions are like that. Now the middle part is hard. So the middle part, let's see, the middle part we can see x-intercepts. That's when the numerator is equal to 0. That's plus or minus 3. Let's find the y-intercept. Y-intercept, we know we just throw in 0 for x. That's negative 9 over negative 25. Whoops. So that's 9/25. I know the scale's off, guys, but this is just a sketch. So now look, the general shape of this, and you could test some more points, but the general shape is going to look something like this. Okay? I might not have the highest point, but I have, it's a reasonable sketch. Okay? I look at this sketch and I say, okay, when is that sketch, or when is this graph greater than 0? Well, you can see over here you're greater than 0. So that's x is less than negative 5. Or we have x is greater than 5. And then the region, the little hump here between negative 3 and 3. There's my answer. Okay. You can pause it if you have a question, or if you want to look at it again, just rewind. Otherwise, we're going to go to number 4. So here, with the inequality, we had already solved for 0. We factored using difference of squares. We did a graph. That's old material. We found the horizontal asymptote. We found the vertical asymptote. We found the x-intercepts, the y-intercepts. We did a rough sketch, and then we found our answer. Okay, this one is going to be tough. I actually think we're going to need 2 pages for sure, and we're going to go slow on this one. Okay, so this one we're trying to find all values of x. So we can see there's a huge common denominator, but we're going to actually not find the common denominator first. Let's simplify the left-hand side. So here we go. Okay, we'll work on combining the top. So 3x squared minus 3x minus 2x plus 2. Okay, let's clean up this top numerator here. Ooh, whoops. So let's clean that up real quick. So the x squareds are 4x squared then minus 3, that's minus 6, minus 2 is minus 8, and then for the constants, plus 2. Now at this point, I'm going to cross multiply as well. Now look at that, the denominators are gone. I'm going to expand this. For me, it's easier to expand these two first. So I'm going to do these two together. Okay, so it looks like right now we have 16x squared minus 32x plus 8 equals 2 minus 5x times x squared minus 4x plus 3. I told you this was going to be a tough one, guys. So now we're going to FOIL again here, or expand. Maybe that's a better term. Expand or FOIL. They both mean the same thing. So 2x squared. Oh, there's a cube term. Okay, I'm going to double check my work. You guys double check it for me. Okay, I think it looks good. Let's get everything to one side. So you see this 5x cubed. Actually, no, let's simplify here first. Okay? I don't want to do too much at once. Here we go. Okay, so here we go. 5x cubed, that's gone. 2x squared and 20x squared is 22x squared. So those two are gone. Then with the x's, 15 and 8 is 23, plus 6. Okay. I'm going to scoot this up. Now you can see the power of the smart board. Let me see. Oop. Let me see if I have to look at the screen. Sorry, guys. Okay, so I think this is good. So here we go. We're going to write our new equation. So the 5x squared is gone. 16 minus 22x squared, that's going to give you minus 6x squared. Now let's look at the x's. So minus 32 plus 23. Gosh, you can really see how this is so tricky. 23, if you reverse the digits, you get 32. So you might think that they cancel in your, if you reverse the numbers. This is a really tricky problem. So that's going to give you minus 9x. Really tricky. And then I think the plus 2 is clear. So this whole long equation simplifies to 5x cubed minus 6x squared minus 9x plus 2. Okay, think back to the polynomials unit. We learned synthetic division. I always said start with 1 or negative 1 as one of your test points. So let's try negative 1. So we write out the coefficients in order. To the third power means you're going to have 4 terms. 5, negative 6, negative 9, 2. Let's do negative 1. Negative 1 times negative 11. Okay, it works. So this means x plus 1 times 5x squared minus 11x plus 2. This can be factored. You could also use the quadratic formula. So 2, it's got to be 1 and 2. And it's got to be minus minus. Again, guys, this is a tough problem. So we're thinking the answers are negative 1, 1/5, and 2. Now let's just go back real quick and see, are there any possibilities for extraneous solutions. So the equation was this. Okay, so here's what I want you to see that, okay, if you had 1 for an answer, it would be extraneous, but you don't. If you had 3 for an answer, you'd have it be extraneous. If you were allowed a calculator, you could check all the solutions. You can definitely check pretty easily since these 2 answers are integers. So you could probably, even without a calculator, do 2. Like if I want to check, let me just finish off right here. Let me check 2. Okay, so if I take 2, 2 minus 1 is 1. 6 minus 2 is 4. 2 minus 3 is negative 1. Does that equal? So this here is going to be 2 minus 2. Does that equal 2 minus 10 is negative 8? Oh, well, you guys see what I just did? This is 4 over negative 1. Sorry, guys. This is 2 minus 4. I was going to say this doesn't seem right. 2 minus 10 is negative 8 over 4. Negative 2 does equal negative 2. That works. So 1/5 would be sort of tricky to check. So I would say you'd assume, unless you had a calculator, which I haven't decided what to do about that, but negative 1, 1/5, and 2 definitely work. And as long as you're not dividing by those answers, if it was no calculator, you'd know that these 3 answers work. All right? But we'll talk about calculator use in class. All right, guys, I hope you're having a great day, and I will see you next class.